In this video, I want to talk about functions that are able to throw errors in F#. I want to talk about how we can treat those in a proper way and sort of do proper error handling on these errors very explicitly. I want to structure this discussion around two functions. A simple function called divide that I'm going to define here. I'm going to call it divide1 just because we're going to define two of these. And we would simply divide two numbers in this function. So I'm going to need two function inputs like this. Okay, and the idea is we want to build a function now that can divide these two, but when we do so, we would potentially expect an error because the user might give us a b value that is 0, and in that case, we're not going to be able to divide them because, well, you can't divide something by 0. We want to build the appropriate functionality around that and give sort of a good structure for error handling in case the user does provide that. And a naive implementation of this might be to simply do like this. So we check if b is equal to 0. In that case, we would return, let's say, a value or an option value that would correspond to our division at the same time as we return an error. That would be one way of sort of solving this. Let me show you so you actually see what that looks like, just to make it more clear. So here we would normally put the value, but because b is 0 now, we can't divide, so we would provide none there. And then we would give it sum, and then some text here explaining the error. Cannot divide by 0. So in this sort of implementation, we very explicitly return two values all the time. If this actually does work, we can also return two values, just that here we would provide sum and then our value, in this case a over b, like that. And then here we would provide none. So we can do that, and then we would have two very explicit types that we always need to catch on the other side and build functionality around. So a way that that would look if we wanted to call this function would be something like match divide 1, and we would give it just two values here, 1 and 2, with, and then we would provide some pattern matching functionality here. We could say none, and then sum. We can call this error like this, and here we would do some sort of print fn. This would probably be a more involved error handling procedure, but nevertheless, here we would simply say that we print the error message. In the other case where we have some number here, let's call it num, and no error, so none here, then we could define the other thing, and here we'll probably have some more involved functionality again, but let me just do a simple print statement here. Evaluated successfully as, and then a num. Okay, if I execute this, we'll see what we get. So as you can see, we get an output here, evaluated successfully as 0.5. One more thing to note is we get a warning that says incomplete pattern matches on this expression. So this has to do with the fact that there can be more combinations of these values that we're not catching here. You could define the other cases as well, but we know from the implementation here that just one of these two is going to happen in practice. But this is not the best code practice if we think about it. First of all, if something here changes, we don't have complete pattern matching, and we're not going to get an error for that. We're just going to have this warning. So it might be that in the future, someone does a change to this code and it actually starts breaking or doesn't work the way we intended it to. Another problem with this kind of implementation is that if the user doesn't really know about the return type of this function, you can see that we didn't explicitly define it here, then they might not know that one of these parameters is an error. It might just care about the first argument if they're kind of sloppy and they implement some functionality, and it's not great practice because there's lots of ways that there could be a misunderstanding in this implementation, and you could put something in place that ends up screwing up your code maybe in the future. What's a better solution for this is to use the so-called result structure. This is a structure defined in F#, and that's why I imported system.io in the beginning here. We're going to make use of that now to create an alternate implementation of this. I'm going to define a new divide function, divide2. It's going to take the same input arguments. So let me just copy that right here, like that. But here in the return type, I would now specify that this is going to be a result type. And here I would put float and string. We're going to see what that corresponds to in a minute. But this result type is predefined in F#. And it helps us to implement functionality that could throw an error so that we can handle it very explicitly in our code. Okay, so let's define the body of that as a starting point. Let me just get whatever stuff we had in the beginning here. I will put that in, but rather than having these two clauses when we have a result correspondingly not, we would define slightly new functionality. So here, in this case, we would define what's called an error, like this. This is not an error type. This is just the corresponding thing you need to write when you have this result type and you want to return that. And in this error, we would provide the same message as before. This is the reason why I provided string here in the type implementation, because the result type has an OK statement, which is when the evaluation worked, and the type of that statement needs to be, in this case, float. And if it doesn't work, we will throw an error with the type specified here, in this case, string. So I provide a string in here, and if it works, then I'm going to say OK, and I'm going to put the return value that we wanted to put there, like this. So you always have to, when you implement something with this return type, provide either an OK value as the return or an error value like this. The benefit of this is when we implement this, we can do a match on our result. So we would do divide 2, and then we can provide the same values as before with, and then in here, I could either say error and then message. And here I would actually copy over what we had from here like that. I just have to print the message, and in the other case this is going to be an OK type, num here. So I copy this over like that. If I try to evaluate that, we're going to see that we're also able to evaluate this and get a result. We evaluated successfully as 0.5. You can see that we don't get a warning here because now we match completely all the different cases that we could get, because this result type only returns either an OK statement or an error statement, and we can do pattern matching on those directly. Another thing this does is it only gives us one output parameter whose type depends on whether or not the evaluation was successful or not. So this gives a much more robust way of writing code that we know can throw errors, and gives us easier ways of handling this code. Because here we could do the appropriate error treatment. If we do some changes to this in the future, it's not going to be a change to the pattern matching style, because these two types are the only types that we could ever have when we return a result. And overall, it just makes the code more robust and easy to read. So that's a good way to implement error-prone functionality in F#.